Yeah, so you're free to leave at 3:30 or you're free to take the quiz too if you want. Um, what else? There is a homework assignment. So that one I will follow up with an email after today's session. You'll get the files, the instructions, everything you need. Okay. Um, Great. So let's get started. The material for today is shell scripting. Here we have a brief review on what we covered on day 1 and day 2. These are some of the functions that we cover, how to log in, log out, pwd, cd, pretty much the basics for you to move around Hotman and Unix in general. And here we have some commands that we also covered for you to manipulate files. We also looked at some more commands for piping, combining different processes, more file manipulations and reading of files. There are some functions over here that we did not get to cover, like def or set. We're going to cover today Z very briefly. But of course, none of this is going to be part, on your quiz, so you don't need to worry. Okay, so let's start with shell scripting. Let's switch to your terminal and log into Hoffman 2 and to your Unix workshop folder. Actually, we should all, let's all go ahead and request an interactive node. So just, here's the command. We're requesting 3 hours and 1 GB. Does everyone have their node? Me? Yeah. Okay. Let's just do a quick show of hands once you have your node. Okay. Okay. Yeah. Okay. That's everyone? Okay. Let's move to our Unix folder again. And so far, what we have been doing is what we call coding interactively. And what that means is that you type one line of code, like echo hello, and you get the output right away. And this kind of programming is, of course, as you can imagine, not very practical for real applications. It's not convenient to type the code line by line and having every intermediate step spit out something. Um, we talked about piping, which is sort of a way of combining multiple lines of codes. So like, for example, opening some file, maybe selecting some columns and sorting, doing some sort of analysis, right? So what we want to do now is to actually write a script that will automate all these steps. You can think of, for example, here we're writing some bit of code that is going to process a file a certain way and give you a new version of that file, right? Now, what if you want to do that process 100 times or for 100 different files? So the best way to automate that is to write what we call a shell script. So we're going to use our editor, VI, and we're going to call it just script.sh. Okay, so sh stands for shell script. Shell, it's pretty much within the same family of bash, which is like the programming language we're using in the Unix interface. So this just indicates the programming language we're using to write our script. So let's do vi script.sh. Okay. And now here we can write our function. So let's start by just printing some commands. We can do echo hello. We can also do ls. We can list what is in our current directory. Let's see what else. There are some built-in functions on Unix environment in general. So for example, if you type date, it will print out the date and time. Okay, let's see. What else? ls, and let's do one more thing. Echo user. Okay, now here I'm introducing a new variable. This is what we call an environmental variable. Now, what is an environmental variable? These are the kind of variables that are already predefined for you. So usually when you write a script like this, before you call a variable, you first have to define it, right? So for example, variable 1 equals 5, and then next time you call variable 1, it knows what variable 1 is. An environmental variable, like the user over here, is already predefined for you based on the operating system. So this command over here is just going to print your username. Now, I'm also putting a $sign in front of it, right? So this is in general to call a variable. Here, now when you're writing a code, what is common is to put comments. So the comments are lines of code that are just for you, or just your notes. They're not going to do anything. They don't affect any other line. So it's just for you to write some comments about your code. So here I'm going to put print environmental variable user. Okay. What about a regular variable? So here I'm going to do regular variable. And I'm going to do school equal UCLA. And now here I'm going to print school. Okay. So here we're doing a few things. We're using a built-in date function. We're just doing a simple print command, listing. Here we're using an environmental variable. And here we're using a regular variable that we define ourselves. Yeah.
Can you follow the reading for the ways to have regarding the
Oh, good catch. No, it depends on how you define it. So this should be lowercase. Yeah. Thanks. Any other question? Okay. So another thing about variables in shell scripting is that the minimum requirement is that they have the dollar sign in front of the name. So for example, this would have been enough. Okay. So most of the time it's a good practice to put variables that are strings, so letters in quotation marks. So this helps you distinguish different types of variables. Sometimes you may have numbers or arrays or some other type. So this just makes clear that you're printing just a string. Another common way that you may see variables is in between curly brackets. So something like this. That works the same way, and it's also not necessary. But it is a convention in case you have multiple variables together. So if I was to do something like this, so here I'm say I want to print 3 variables consecutively. So a good way to separate them would be using the curly brackets. So these are just notations to make your code look cleaner. But once again, the minimum requirement is just to have the dollar sign in front of the variable name. Okay. Any questions? Great. So let's exit the editor. And now I'm going to type bash in front of it to run the commands. So this is what I get. Here's my first line. This is the current day and time. Here we have hello. These are all the variables, all the folders and files I have in my current directory. Yours may look a little bit different, but that's okay. This is my username. And here, this is the school variable. Okay. So once again, here are the lines of code that we typed. Okay. But so far, our code is a bit static, right? Like it's just doing the same thing. How do we add more variables to it? So one thing that we can do is pass arguments. So what does that mean? Here, I want to, for example, say hello plus a name, right? So I'll do hello, and I'll write a new variable name. Okay, and now I need to, name is not an environmental variable, so I need to define what name is, right? So here I'll do this. Name equals $1. Sorry, 1. So what that means, this is a special kind of variable, and this is reading directly from the command line. So $1 means the first argument after the script name. So let me give you an example. I'm going to run bash script, but now I'm going to add a new variable, a new argument to this function. For example, John. And now when I run this, here I have my function, hello, John. So the $1 that we use is referring to the first place in the arguments position. An argument is pretty much anything that follows the script name. So if I wanted to do hello, John and Mary, I could define, let's say, I could do like name first, name second, and now here, name first and name second. Okay, so now let's test it out. I exit, I save, and I'll put John and Mary. So now I have my output here. Hello, John and Mary. Okay. Yeah, so this will happen sometimes. If you have connectivity issues, you'll just lose connection to Hoffman. So let me just log in again. Has anybody lost connection to Hoffman in these 3 days? No? Okay. Yeah. Oh, you did? Okay. And you did too? Yeah. Um, yeah, it's not super common, I would say, but it does happen sometimes. Let me log into. There's also something called latency. For example, if your computer itself knows that you're being inactive, like it could cut the connection itself. So there are ways to log in with special arguments. So to make sure that every 5 or 10 seconds it checks that you're active, and it makes sure you don't lose connection due to inactivity. Um, yeah, I can share that with you guys later. So far our function, our script is only doing printing work. It's printing different variables. So we can ask it to do something more interesting, right? So for example, we know the ls command will list all the files in the current directory. So here we can write a function to count the number of current files. So I can do ls Now I just want to count number of files in my current directory. So ls by itself works. I can also do ls dot. That means ls current directory. I can do ls asterisk. So ls all the files. All three of these ways are equivalent. They'll work the same. These are just redundant arguments, but just so you know, these are the different ways you can do it. Let's keep it simple for now. Let's do ls. And now, what do we do to count stuff? What's the command? wc-l. Yeah. So yesterday I introduced this to count lines in a file. But remember what we said before. For Unix, everything is a file. So when you do ls, it's treating it as a file that contains the name of your documents. So you can use this the same way to count the number of files. The same way that you count the number of lines in a file. And before this, we can do something like echo. Here we're gonna get the number, and we can do echo again, files, right? So there are this many files. Okay. Yeah, this is just so you know what the number you're looking at means. Okay, so let's test it out. Let's go back. And so, yeah, we can run it just like this because we're not interested in saying hello to John and Mary now. So I can do bash. Oh, yeah. Do you put the dollar sign? Okay. Yeah, make sure, yeah, without the dollar sign, then you're just printing the variable name. Okay, so now over here we have our output. There are 6 files. And as you can see, we have 3, 6. Okay, let's look at some more examples. Okay, just to make things clean for now, not mix all these different lines, I'm gonna delete this. And also the name first, second. Okay, so I'm just deleting all this line. Another tip to delete is if you exit the insert mode, so with escape, and you can just move to the line you want to delete, and you press D twice, and it will delete the entire line. And you can press U, and you can then press U to undo. So once again, make sure you're not on the insert mode. You move to the line you want to delete, double D deletes it, and if you want to get it back, U undoes the previous command. Everything except this part. Yeah, just to keep it simple. What do you Oh, yeah, yeah. Okay, so what I want to do now is, if you just run like this, this is going to print 3 different lines, right? So let me just show you real quick. So there are 6 files. But okay, so I only care about the number 6 though. How can I save a command, in this case a piping command, into a variable? So the way I'll do that is I'm gonna call it n or nf for number of files equals $ parentheses. So what I'm doing here is I'm wrapping the command, the piping command, into a variable, right? So instead of just running the command and getting the output right away, I'm saving the output into this nf variable. Okay, and now I can do something better. I can do it all in one line. There are nf files, and I don't need this one anymore. Okay, so once again, once you have your piping command, you get an output. And if you want to save this output to use it later, you use this wrapping function, which is just parentheses plus $, and you save it into a new variable. And now you can use that new variable over here. Great. So let's test it out. Gonna exit, save. And now we have it all in one line. There are 6 files. Mhm. Can you guys see it clearly? Or is it too bright? Is it okay? Okay. Okay. Yeah. So let's very quickly review what we just covered just now. We're writing a shell script where we can save our code to be reused over and over again. There are some built-in functions like date, which is a good practice. It's always good to put the date at the beginning and at the end of your code so that you have a record of when you run it and also how long it took to run. Okay. You can define your own variables like we did with school equals UCLA. And then later you can use this variable for later functions. So let's put up home variable. There is environmental variables that are previously defined for you. The one we looked at was user. Let's see. There are other variables like, for example, path. This will cover a bit more later, but let's see. Other one. What's another environmental variable? We can do home. This will show you what your home directory is. And let me go back to the slides. In the slides, we have a few examples. Okay, so user, we can, oh yeah, we can also look at our host name. So user, that's your username. Path, this is an environmental variable that contains the directories from which you are borrowing functions. So that's going to become a little clearer later when I show you an example. But you can think of this as your source of functions, wherever you are extracting functions from. Home, this is your home directory. And host name, this is the name of the node, the computer you're currently hosted in. Okay. So that's environmental functions. We looked at how to here how to wrap a command and then use it. And the last thing we looked at was how to pass argument. So we can have something like argument at the first position. And that was our example of saying hello argument. Or I think I used name, yeah, just to keep it consistent. Name. Okay. So this is what we've covered so far. Defining variables, using environmental variables, wrapping commands, and passing arguments. Okay. Any questions? Yeah. Uh, this? That's an L. Yeah. As an error. Oh, can I see? Oh, it is. Oh, no. After the WC. Yeah, I guess that's something I should have probably also mentioned before, because I've seen quite a few times where students get mixed up with the spaces. So the general rule is, so in general, you have function name, space, then you have your additional parameters for the function. So in this case, -L, or we can do -C. Sometimes you can have multiple parameters, and each parameter should be separated by space. So I don't know if this specific example would work, but this is just to show you. You can have your function followed by multiple parameters, and then you need your object, right? Whatever you're running the function on. So in this case, it would be a file name, all separated by spaces. Okay, that's in general, it doesn't matter if you have multiple spaces like this, because when you run it, it just knows how to ignore additional spaces. So this would still work. Now, if you don't put the space, the Unix is gonna think this is the function name, this whole thing, right? And it doesn't know what WC-L is. So it's gonna give you an error. Yeah. So some functions, not all, but some functions allows you to combine parameters. So for example, if you're doing something like this, it's equivalent to writing something like this. So you just put all letters together. But I would avoid doing this because it's not always gonna be the case. It depends on the function. And especially if you download some program online and different developers have their different ways of putting arguments. So I would just keep it all separate just to be clear. Okay. So talked about environmental variables. Now, I mentioned very briefly this path variable. This is a very important variable that once you get used to the command line and you start installing your own programs, you're going to have to deal with this path variable a lot more. So let's look at it. Let's see what it does. I'm going to do echo path. And it gives me this really long list, right? The thing about this list is that it's separated by colon. So here you can see colon. And it's just a list of different paths within your computer. So over here, I have my first path. Over here, this will be my second path, and so on. So it's just a list of paths. Now, why do we need this list? Let me use this as an example. Here we have the Google Cloud SDK. This is its own software. When I add this into the path, then I can directly call functions that are associated with Google Cloud without having to specify where Google Cloud is located. So when you install a new software on your computer, the system already knows where to move it, where to install it, in which folder, right? And then how do you use that program that you just installed? There is the manual way where you have to find the place where it was installed, which is tedious. Or you can use, you can just identify the path one time, add it to this path variable. And so now you have direct access to it every time without having to find it. So let me see here, Google Cloud, I'm gonna go into this path. So these are functions associated with Google Cloud. So if I want to use, for example, gsutil, the manual way would be to type the whole path and then gsutil, right? And then that way I can use this function. But since the path is already in the path variable, I can just directly do gsutil and use it. So it's just you can think of it as a shortcut. It just gives you quick access to everything that you installed. Okay. I think this is gonna, well, anyway. So just to give you another quick example, say I installed something just now. So how do I add it into the path variable? I'll use export. And the way this works is I'm gonna do path, here, new path that I want to add, colon, and then path again. So this is what we call, we're pretty much redefining the path variable, but with the new path added to it, and followed by the export command. This part is beyond the scope of this workshop. You don't need to know how to add path, but here I just want to show you that it is possible for you to add as many paths as you want. So it's really up to you how convenient you make your environment and how quick you access to different stuff. Okay, let's see what else. We have path. We cover a bit about different variables. A variable can be a number, a string, or even an array. Here we have some few notes that I also mentioned, like the use of the $sign, case sensitivity. And let's see. Yeah, here we also cover this, how to wrap functions into a variable. So that'll be using the $sign followed by parentheses. This one I didn't mention, which is an alternative way. So let me go back to my script. So here we wrapped using parentheses, but it works just as well if I use this symbol over here. This is like the, I don't know the proper name, but it's like this diagonal quotation. And the two are equivalent. I prefer the first one because it looks a little cleaner, but yeah, they both work the same. Yeah. Okay, so we covered some of the most basic things. Over here, we looked at the different types of variables, how to wrap commands, and how to print and how to pass arguments. But our script is still not doing anything, right? It's still not really generating new information. It's probably just summarizing some basic features or doing some basic processing. So whenever you learn a new programming language, there are two basic things that you learn first, right? There is the if statements and the for loop. So these two commands, well, they're not exactly written like this, but you can pretty much build any program using if statements and for loops because they are at the basis of any function, any programming function that you use. Once again, we're working on the Unix operating system, and the default programming language that we use here is Bash. So we're going to learn how to how to write very basic if statements and for loops, and run a few examples so that we can make our script actually do something interesting. Okay. Um, we're going to take a 10 minutes break now. And after the break, we're gonna continue with these two comments. So let's do a quick show of hands. How many of you are familiar with any programming language? Yeah, which ones? Python, MATLAB. Okay. Do you raise it? Yeah. In R? Okay. Cool. Yeah. Oh, great. Well, Python, MATLAB. Okay. And do you raise? Okay. Um, yeah. So you probably already know then what's the syntax of an if, then, or a for loop statement in those languages. But in general, as a tool, this is what we call conditional statement. So where we check first if a condition is true, and if it's true, then we apply one bit of code, and if it's not true, then we may apply a different bit of code. For example, if tomorrow is sunny, then I'll go to the beach. I will go to the beach is what will happen if this statement is true. We can also say if tomorrow is sunny, then I'll go to the beach. Otherwise, I will stay home. Staying home is the statement that happens when it's false. So that's the basic logic. We can have more sophisticated cases, like if tomorrow is sunny, then I'll go to the beach. If it's rainy, I'll wash my car, or otherwise I'll stay home. In this case, we're not evaluating one simple statement, but we're going statement by statement and assigning a consequence to each statement if they are true. So if it's sunny, I'll go to the beach. If it's rainy, I'll wash my car. And otherwise would just be like, what if none of those conditions are true? Then what would I do? Stay home. So that's the basic logic of an if statement. Typically, the way it's logically represented is like this, where you have a condition and you have a bit of code if it's true, Sometimes if it's false, you just skip it, or you can also have a different code if it's false. And the way it works for bash, it's written like this: if, then, and followed by the fi, which is like final, which is just an indicator that you are done with your conditional statement. So yeah, so for the if and then statement, the simplest way is what we mentioned before. If something's true, then do this. We can have a more expanded form where we have the two conditions, the two codes for when it's true and for when it's false. In that case, it's if, then, else, and final. Okay, so let's try a quick example. So to keep things clear, let's actually open a new file. I'm gonna call it just script2sh. Okay, so let's start with the basic structure first. I'm gonna do if square bracket. This is where I'll write my condition. Then I'm gonna leave it blank. Else, leave it blank, and then final. So this is the basic structure. Now, one very simple comparison we can do is we can check if a variable is greater than a certain number. So for example, I'll define a variable, say var equals 4. And so here I'm gonna write if var, let's say greater than 3. So for the if statements, typically mathematical notation will write something like this, right? Greater or equal. Or if you just want to check if it's greater, we'll write it like that. For bash, this is how we write greater than GT. So right now we're gonna keep it simple. We're only gonna check if this is greater than 3. Okay, if it's greater than 3, then we're gonna print something. Now here, you don't have to leave an indentation, but it's common practice to leave some space, just so you can easily visualize where your statements are. So here I'll write var is greater than 3. So this is what will happen if the condition is true. If it's false, var is lower than 3. Okay. Now, here we're using the greater than, but if we go to the slides, we see that we actually have like this whole bunch of operations. So EQ dash EQ means equal, GE greater than, or no, greater or equals, GT greater than, less or equals, and so on. We also have some logical operators. But like I mentioned before, these are a bit more general, a bit more comprehensive. And this is the string comparison. We can also do file comparison. So we can check, for example, if a file exists, we'll do the dash D. Check if file exists and is in a directory, or file E, this simply checks if the file already exists. Dash F, check if it's actually a file and not a directory. So we have already some built-in functions for you to quickly check. You can also do like multiple conditions. This is something, we're going to explore that later. But for now, we have our very simple command, bar greater than 3. And here we have two different outputs. So let's go ahead and test it out. So bash script 2, and what we get is 4 is greater than 3. Okay. We can apply something that we already looked at. Instead of making this a fixed variable, we can make it an argument. So I can check a number. So I say I want to check 6, and it will give me, yes, 6 is greater than 3. I can check a smaller number, 0, and I'll get 0 is lower than 3. Also, I think this is a good opportunity to mention this, is that I've written the conditional statement this way over here, but if you check online or if you check just examples online, a lot of times you'll see it like this, with a then up here, followed by a semicolon. So this is the same command. The only difference is that in Bash, you can use the semicolon to indicate a new line. Okay, so this just means this condition or this bit of code ends here, and over here starts a new bit of code. But the representation is the same. Yes. Oh, yeah, that's a good point. This is one of the few cases where it does matter. Like you have to leave a space between the bracket and the condition. Yeah. Bash is a little picky with the spaces when it comes to conditional statements. Like there are cases where if you don't leave this case, it will still run, but some cases where you have to do it or it'll just crash. So a good practice is just in general, leave a space between the square bracket and the condition. Yeah, that's it. This is our bash function. Very quick calculator to see how numbers compare to 3. Okay. Now, of course, that's simple. What if we want to do something more sophisticated and we want to add more conditions? So let's do this. Does anybody know what this means? So 2 straight lines. Yeah. Yeah, almost. It means or. Yeah. So yeah, those of you that know other languages are probably familiar with these logical operators like and, or. Let's start with and. It's a bit more intuitive. So this is the symbol for and. And what it means is that for this thing, for us to consider this statement true, both conditions have to be true. So let's see an example. Bar is less than 10. Okay, so only when the number is greater than 3 and less than 10 we'll print this bar is greater than 3, this statement. If one of the conditions is true and the other one is false, then we'll get the other output. And if both conditions are false, what would happen? Do we get the first or the second output? If both conditions are false. We'll get the second, yeah. So with an AND statement, we'll only get the first condition if both are true. Every other combination will make it false. So let's see. So bar is greater than 3 and less than 10. And if it's false, then we'll put bar is, so it's gonna be either lower than 3 or greater than 10. Now let's test it out. So let's pick a number between 3 and 10. So 7. So 7 is greater than 3 and less than 10. Let's pick 1. 1 is either lower than 3 or greater than 10. In this case, 1 is lower than 3. And if we pick 12, same message, 12 is either lower than 3 or greater than 10. In this case, 12 is greater than 10. So we're only gonna get the true statement if it's a number between the two. Okay. Now, this is the AND command. Now let's do the same for OR. And this time I'm gonna replace this text with, I'm just gonna put message 1 and message 2. Okay. So here is another tip. What if I want to comment out or ignore a complete chunk of code? So say right now, I only want to test the OR command and I want to completely ignore all these lines. So how to comment out? A very quick way of commenting out in Bash is colon lower than sign. And then here you can type any word. So I can put block. So you can see everything change color, right? So everything below this block is getting commented out. And I'm gonna end it here, block. I write the same word. And now only this bit of code is commented out. And this code is active. Okay, so I commented out the AND statement, and now I'm only gonna test the OR statement. So we're saying our variable is greater than 3 or lower than 10, right? And if it's true, we get message 1, and if it's false, actually, let me just put message true. That's more intuitive. Message true, message false. Okay, so same as before, let's try with 1. Oops. There's some error. Did anybody else get this error? You did? Warning. Let me try a different word. Okay. Yeah, apparently the word block was problematic because it probably is another command. So you can just try a different word. Okay, and let's test our script. So we have one message true, and that's because one is lower than 10. So in this case, this condition is true. Let's try, let me copy this so you know what we're looking at. So this is our conditional statement. I just copy here with a comment so it doesn't run. Okay, if I run 7, would this be true or false? Our statement says that the number is greater than 3 or lower than 10. So will it be true, right? Okay, message true. What if we do 2000? Would this be true or false? False? Yeah, it says false. False? Yeah. Who says true? It's true. So why is it true? Sorry? Yeah. So as long as one condition is true, the whole statement will be true. And here we're saying that it's greater than 3. So 2000 will be true. What about, I think this will cover all numbers. Yeah. Yeah, because all numbers are either less than 10 or greater than 3. Oh yeah, no, let's try, well, yeah. Yeah, so for this particular OR statement, actually there happens to be no number for which this is gonna be false. Like any number we put is gonna be true. Okay, so let's change it up a bit. I think the concept is clear, but let's just try another condition to make it clear. So let's do less than 10 and greater than 30. So we're saying the number has to be greater than 30 or lower than 10 for it to be true. So for what number would this be false? 20. Let's try it out. Yeah, 20. 20 is not greater than 30 and is not lower than 10. So pretty much any number between 10 and 30 would give us false. Okay. Any questions about if statements? So we just covered some basic syntax and examples. Of course, there is a lot more operations that you can perform, but for the sake of time, we're gonna wrap it up. We're gonna wrap up the if statement part with those simple conditions. The next part would be to do a for loop. So when we do a for loop, the way you can think of it is an iteration process. So for a given list or array, an array that is a set of objects, you can do some operation, you can do some command one by one. So in this diagram, it would be like testing for, you can do like the for loop over here, and you can run any expression that you're interested in. And this will circle, it will loop back because we are doing it one by one for every element in the array. So let's do one quick example. Let's write a new script. Let's call it script for loop and .sh. Okay, so the same as before, we're going to start with the basic structure. For, followed by do, and finally done. So just as a reminder for our if statement, we had if, then, and final, or we can alternatively have an else statement. So if statement, for loop, so the two different structures. Okay, so let's start with something very simple. Let's just iterate over numbers. So I'm gonna define a variable j in, now there are many ways to represent arrays in Bash, but one simple way is just to write the elements that you want to test. So for example, 1, 3, 5, 8, 9. So for every number, we're going to print echo current number j. Yeah. So once again, for a for loop, we're going to iterate over this list. So j will equal 1, and then 3, and then 5, and so on. And for every value of j, we can run some function. In this case, we're just printing a message. Right? So let's test it out. And now you should get a list like this. Current number 1, 3 with each number of our array. Right? Now, what if I ask you guys to print all the numbers from 1 to 1,000,000? One way would be to type every number from 1 to 1,000,000. But you can also do sequence. And the way you write a sequence in Bash is like this. So curly brackets, start, dot, dot, end. Now, of course, I don't want to print 1,000,000 numbers in my screen. Oh, well, actually, why not? Let's just try. And there is it. Here, we have the numbers from 1 to 1,000,000. Okay, you can test it out with a lower range, but just in general, you can write a sequence like this. Alternatively, you can write it like this. Now, you guys remember what this is? $, parentheses. Yeah. Good. Exactly. Yeah. Wrapping a function into a variable. Yes. Okay, so we can iterate over numbers. We can also iterate over files. So let me just make this number smaller. And let's see. If you remember, we have an assignment folder. And inside this assignment folder, I have several assignment files, right? So I'm going to copy this. And I'm going to do for file in, I'm going to wrap ls assignments. So I'm going to iterate over all the files that are present inside this folder. And for each of these files, I'm going to, let's see, I'm going to show the number of lines. So number of lines, I'll do file, and then I'll print. File has ML lines. Done. Okay, so once again, what we're doing here, NL, here we're wrapping this function into a variable. We're calculating the number of lines for each file, and we're iterating over all the files in assignment. And then we're just printing a nice message. This file has this many lines. Now, let's test it out. Oh. Um, oh, wait, hold on. I think I made a mistake. Has Oh, yeah. Yeah, sorry. I made a mistake. So you should do it like this. Because what happens is, let me show you. This is my current directory. In my current directory, I have the assignments folder. Now, what if I do ls assignments by itself? It gives me the file name, right? And then what if I do this on the file name? Uh, does anybody know what will happen if I just run it like this? It's not gonna run, right? Because assignments is not on this directory, it's on this one. So for this to work, I need to type the full relative path. So this works. And if I put it like this, it's just gonna tell me there is no such file in assignment. And so when I do ls like this is actually showing me the entire path. So let's try again. Okay, so now I have all my files and we have the number of lines. This one has 1 line, 0, 0, 3, 1 line. Let me show you the code again. Okay, so I think we've covered enough of basic commands and we know how to write a script, a shell script, and how to run it. This is one example of that. So what's next is to actually use the cluster to run a job. Um, on the Google Doc that I uploaded, let me see, where is it? I copied a link. Please go onto that link. And it should get you to this website over here. Okay, so this is a template provided by Holtman 2 for a file that you can submit into the cluster and run. So as you can see, it has quite a lot of things on this. The majority of these commands are not super necessary, but we're just gonna go over them really quickly. Let me zoom in a bit more. We're gonna go over these commands so you guys are familiar with what's needed to submit a job. And then we're gonna submit our job ourselves, okay? Yeah, so when you copy this link, oh, it doesn't take you directly there. Okay, you need to scroll down a little bit to this basic subscriptions script. Okay. Now, if you look at this first part, you can see that all the lines start with this numerical mark followed by the $sign, right? And then we have some parameters. So these are all the arguments that you're passing onto your script that you want to submit. And you're passing arguments such as, for example, -L over here. You're indicating how much time and how much memory you're requesting for this specific job. So the same way that we request time and memory for an interactive node, for a computing node, we request resources for a specific script. Here we have other parameters like psure. This indicates how many individual compute nodes you are requesting. So this is useful when you're running jobs that run in parallel, right? So in that case, you need multiple nodes. For most applications, you will just need only one. You can put your email address so you get notified when your job is completed or if it failed. Here, this is just a code abbreviation. So to indicate what exactly do you want to indicate. I don't know the specific meaning of BEA, but you can specify, for example, only notify me when it's completed, or only notify me if it fails. Or maybe you want to know everything, notify me of everything, when it started, if it fails, if it succeeded, and so on. You can specify with this over here. You have this over here, -O and then job log. This is where you want to direct the output for your script. So if during the script you are printing messages, so where is it going to print, right? So remember, you're submitting to a different node, not the node you're working on. So whatever you print is not going to show on your command line. It's showing on a different computer in Home. And this one over here means current working directory. So it just indicates from what location you're running your current script. For most of the time, it's going to be your current working directory. But there are certain cases where maybe you have a lot of your files on a different directory, but you have your script on this directory. So you could change this parameter. Of course, that makes things more complicated. It's always easier to just have everything you need on the same directory. Yeah, so these first few lines are arguments, things you need to run the job. All these lines over here, a lot of these lines are just notes for yourself. So like I mentioned, it's a good practice to indicate when you're starting to run the job. So date and time and what time it ends. You can also specify the host name. So that is the specific computer that run your job. Um, so when could this be useful? I noticed that sometimes when you install something, it works really well on some nodes on Hoffman, but not so well on others. So you can make a note of which host names your script works well and in which ones it doesn't. And you can even request specific nodes. Like I want to run my job on this specific host. So this is that's what it can be useful for. Now you have this block over here where you're loading a module. This I also very briefly mentioned during the first day. I mentioned that Hoffman has a list of scripts software for you to just borrow and use. So you don't have to install everything in your directory. And this is the way how you do it. In this example, you are loading the GCC module that is used for C++. Um, so let's go ahead and run. Well, before we run into Hoffman, I'm going to show you a bit more about the modules. So on Hoffman 2, there are some built-in functions like module avail. And if you just type this, you'll get this extensive list. These are all the programs that are already installed on Hoffman 2 that you can use. So if you do single cell work, you may want to load Cell Ranger. For those of you that use MATLAB, here you have multiple versions of MATLAB. See CUDA, if you're doing some machine learning, it's pretty comprehensive. You have different versions of Python, different versions of GCC. Say I want to load Python, and I want to load this specific version. I can copy, and I'll do module, load, and the name of the package. If I just do Python, just like that, it will load Python 3.96, usually the latest version that is available. But if you want a specific version, you can write it like this. And now I have Python 3.7 for me to use. Can do 3.7. And here I have Python. Okay. So that's what we mean when we do module load. So just load different software for you to use. Okay, so let's create a new file. And let's call it Hoffman2 test.sh. Okay. Now, what I'll do is I'll go to this website. Since we have a template, I'll copy everything. And I'll just do copy paste. Oh, it looks like I didn't copy the first line. Okay. Okay, now let's go through these lines one by one. The first one, bin bash. This just means that this code needs to be executed using bash. Um, it's not super, I mean, it's not super necessary to specify, but you can do it. I guess it's also a good practice to put, what kind of code you're writing at the top. Then we have CWD. This is our current working directory. We can leave that. Output job log.job ID. If you notice, this job ID is a variable, right? So this is a Huffman-2 specific environmental variable. So every time you run a job, it's going to be assigned its own unique ID. So you can save the log or the output for that specific job using the ID. This command over here, it means whether you want to merge standard error with standard output. Now, we didn't talk about that, what that means specifically. You can think of standard error as error messages, warnings, all of that, and standard output as things you print, like all the echo commands. So this just means that all the output will go to this same file over here. We're requesting 1 hour and 1 gigabyte. I think that's plenty. We don't need multiple cores. One is enough. Now you can choose if you want to be notified, but since we're just testing it out, you probably don't want more emails. But I'll leave this up to you. You can replace this with your email address. But I'm gonna choose to not do that. And because I'm not getting email, I also don't need this. Now, here we have this information about the host name and the date. We can leave that. Now, this I should clarify a little bit more. On the command line, we do this directly, right? Module load plus the name of the package that you want to load. For when you submit a job to Huffman, you have to include this line previously. This line, it just tells Huffman where to look for the modules that you want to load. It's something that is already built in the login and the computing nodes, but when you submit it to the cluster, you need to specify. It's just a weird technicality. But of course, it's something that you can just copy paste every time. Now, for our purpose, we don't really need to load any specific package, but we can leave this as is just as a trial. In the future, when you need to actually load something, you just need to replace this with the name of your package. Okay, and over here we have the actual command. Here is just timing. This function is just giving you like the total time that it takes to run this to get information on the host name. We're going to replace these lines of code for something else. Our job will just be a simple for loop. Let's do numbers 1 to 20. Current number. Okay, and here I'm going to introduce one more built-in function. Because this will literally run in less than a second, we're going to put sleep, and let's put 1 second. So sleep is a function that just means wait. So it means that it will print this the actual time is like super fast, like fractions of a second. But then after it's done printing, it will wait 1 second before iterating to the next number. So that's all we're doing. Okay. Okay. So are we all good here? Okay. So let's go ahead and submit our job. Now, this will depend how busy the cluster is right now. I can't promise it will run like during this workshop time. Let me check. This command lets you check how many jobs are being run right now. See, there is always like several hundreds of jobs at once. A good way of telling, well, I mean, there's no good way of telling how long it's gonna take, but if you wanna get an idea, you can scroll down until you don't see the R. Yeah. So R means this job is currently running, and QW means is waiting in the queue. So for example, this is the next job that's gonna run, and it's been waiting since, oh wow, January 5th. Okay, wow. Here we have something more recent, January 12th, 2025. Wow, that's last year. Anything from this year? January 8th. Yeah. Another thing is that, some of these jobs, it's not that they've been waiting for a year. It's just that, they're pretty much just forgotten. Like they will never be assigned a node. Um, wow, there is a lot from last year. Okay. Okay, yeah, I can't promise you when it's gonna run that, but I'll show you how to run. Now, here is your script. If you remember, we're doing bash, and this runs on your interactive session or your local computer. But if you want to submit it, you do qsub. You do qsub, and you'll get this message. This is your job ID, and it just tells you that it has been submitted. Now, if you want to check on the status of your job, you can do my jobs. So again, these are built-in Hoffman-2 functions. And in my case, my jobs is showing me 2 active jobs. The first one is the interactive login. So we should all have an interactive login. And the second one is the one I just submitted. So the interactive login, of course, is running, is active. And this one is waiting. So what we bioinformaticians do is every now and then we check to see if our jobs are running. Oh, it is running, okay. And we're iterating numbers from 1 to 20 with 1 second wait time, so it should take 20 seconds. So it started at 24:33, so it's probably done. Yeah, it's done. If it doesn't show anymore, that means it's completed. It's waiting, or okay. Is anybody complete? Okay, waiting, just waiting, okay. Just running, okay, great. Now it's running, right? Okay, so what is running? I can show you this file. So if you remember, on one of the parameters that we specify, we say we want the output to go onto this file, right? Job log followed by the job ID. Now I see that file is over here, job log followed by job ID. Here I have my information, host name, date, and this is the output from my code. And then ends with host name and date. So we see started running at 24 minutes with 33 seconds and ended 24 minutes with 54 seconds. So 21 seconds, which, yeah, sounds about right. Okay. It will also, yeah, if we had an arrow, it will also show on that file. Right? Are we all good? Great. So that wraps up the material for this workshop. Now, once again, if you're not taking the quiz, you are free to leave. Yeah. Okay, yeah.
What you said that we got into it.
Yeah, that's all you can do. Yeah. You have to wait until it runs. Yeah. Any other question? Okay. Yeah, so I was saying that wraps up the material for this workshop. If you're not taking the quiz, you're free to leave. And if you are taking the quiz, we still have time for a quick break. So you can take a 10 minutes break and then we'll review the material. Yeah, sure. Yeah, if you want. Yeah.